All right, today we're going to talk about graphing exponential and logarithmic functions. We have a little bit of background information about each type of function that we will discuss first before we get into that. Okay, so if we talk about exponential functions, if you remember from when we were solving them, to be an exponential function, you have to have a variable as an exponent. And when you graph that, it will graph as a curved line. So it'll have a curved line. And part of that will either go to the growing or to the decaying forever and ever. So then here is an example of what the function could look like. F of x, or the letter y, equals b, which would be your base, raised to the variable x. It could be minus h plus h. And then you could have plus k, minus k. And then some information you need to know is that these types of functions will start out horizontally. So they will have a flat part going horizontally, and then they will start to curve. And then as they curve, when they curve, they will end up going out vertically forever and ever. These types of graphs will always have an asymptote that is going to be a horizontal one. So remember, horizontal asymptotes will be y equals, and it will always be y equals whatever the k value is. Okay, so they will have a, I'll put that over here, they will always have an HA for horizontal asymptote, and it will always be y equals k. To be a growth, you would look at whatever's in the B spot, and that would have to be larger than 1. To be a decay, you would look at whatever's in the B spot, and that number would have to be between 0 and 1. Now, if you don't have an equation, like in our examples down below, we'll look at the picture, and then I can tell you when you're looking at the picture how to determine if it's a growth or if it's a decay. Okay, so let's jump over to the log function. Well, to be a log function, it has to have a log. It is also going to be a curved, just like the other one. Okay, so it'll start out with f of x, or y again, and then you'll notice it has log, and then it'll have a base number, b. And then in your parentheses, you could have x minus h, or it could be x plus h. And then outside the parentheses, you'll have either a plus k or a minus k. So this one is going to start backwards from the exponential. So instead of starting horizontally, this one is going to start vertically. So it's going to start vertically, and then it's going to curve, and then when it curves, it's going to end horizontally. And then this one will be a growth, and a decay, this will be the same, except for you're looking at B, and B is located as the little base number for the log. So still a growth if it's larger than 1, and still a decay if it's between. Oh, kind of skipped over this part. Whoops, don't want to do that. Asymptote. So this one should have a vertical asymptote. So I'll put VA here, vertical asymptote. And that will be x equals h, and then you'll see little asterisk, asterisk, asterisk. And if you look up here, you must remember to change the sign of h, because in my equation it's a negative h, but down here I put a positive h. All right, so let's scroll here and try our first example. Okay, so first thing we have to do is we have to determine if it's exponential or if it's log. So we need to determine, how does it start out? Okay, does it start out going, and if we look back up here, you'll notice that it says, if it starts horizontally, it's exponential, and if it starts vertically, it's log. So if I look at this problem, I'm going to notice that this problem is starting horizontally, because you notice here it starts horizontally. So if it's starting horizontally, then that's going to make this one exponential. And if it's exponential, we know that it is always going to have an horizontal. So it's going to have a horizontal asymptote. Oh, I guess I can just abbreviate horizontal instead of putting HA. Or if you want to put HA, I don't know which way you like better. Horizontal. And then growth or decay. So now we don't really have an equation, so we can't really look at the letter A, or I'm sorry, the letter B. So let's figure this out. Okay, to be a growth or decay, when it's an exponential, so this is only good for exponential, okay? So what you're gonna do, here is my horizontal part. You're gonna look at the ending part. So if you look at the ending part, and this is where it's ending, is over here. So if you're looking at where it's ending going up. So if it's ending going up, then on the right side it's ending going up, then that's going to make it a growth. Okay, so let's go to the next one. So on the next one, if I look at the graph, so right here I'm looking at this piece, and I'm going to notice that this piece right here, this one is a vertical piece right here, and if it's starting vertically, that's going to make it a log. And if it's a log, we know that the asymptote is vertical. So I'll abbreviate vertical. Now, for this one, to tell if it's growth or decay, we're going to look at where it's ending. So then I'm going to say this is the part where it's ending. And where it's ending, it's going down, okay, because it's ending downwards. The curve is going downwards. So since it's ending going downwards, I would want to say that is a decay. Okay, C. If I look at C, I'm going to notice right here this flat piece where it's starting. That flat piece is horizontal. Okay, and if that flat piece is horizontal, then that means it's going to be exponential. And if it's exponential, it's going to have a horizontal. And then we need to look at where it's ending. So then I notice that it's ending here. And then it's ending going down. So if it's ending going down, then that's going to make it a decay. Okay, next examples. This time we don't have a picture to look at. We're going to have an equation. Okay, if this equation here has a log in it, then we know log questions. If you look back up here, log questions. It says log questions are going to start out going vertically. So it's going to start going vertical. So I'm going to put vertical. And then what type of asymptote? So if you look up here, log questions, what type of asymptote do they have? They have a vertical asymptote. And then growth or decay. So for this one, it says to look at the letter B, and B is the little bitty base number below log. And if I look at the little bitty base number below log, our base number is 3. 3 is larger than 1. So if it's greater than 1, that makes it a growth. Okay, so I can put that down here just so you have that. Okay, now to sketch it, we are going to use a graphing calculator to help us do that. So here's my graphing calculator. We're going to go to the y equals key, clear out anything that's there. Okay, so I'm going to type in my 2 first. Now, since my base number is not 10, I can't just hit the normal log key that's out on the main screen. Since my base number is something besides 10, I have to hit a different button. So here we go. You're going to hit the math key. And then I want you to scroll down. So keep scrolling until you get to where it says log base. So right here it says A log base. If you hit that, then you'll notice log will pop up and it gives you a little blank where you could type in a base number, and then it gives you the parentheses where you can type that part in. So our base is 3. And then we're going to arrow over and type in x minus 2. Okay, and then we can hit graph. Now, the only thing you have to realize about the calculator here is that this part of the screen right here, the calculator does not continue this line on, but this right here would be a flat, like we talked about, vertical line right here, because it's going to start vertically. So the calculator won't show it going all the way down, but you should just have a flat vertical line right here going all the way down right there. And if I go back here, let me go back here to this part. Whoops, sorry. Let's go to this one. Wrong button. Here at this asymptote, let's, besides putting vertical, let's change that. Let's go ahead and put what is the vertical asymptote. Okay, so here, let's go ahead and just put what it is. So let's go x equals, and then what you're going to do is you're going to look at what's inside the parentheses here, and the number that's in the H spot is the -2, but remember we talked about with all the asterisks up here, asterisk, 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 change the sign of H. So please don't write down -2, you're going to change that to +2. Plus, whenever you look at the picture here, you're going to notice 1, 2. This is where your flat line right there should be going down, that the calculator is not showing, is at +2. So that's going to be where your asymptote is at. Okay, so For sketching my picture, I'm going to go ahead and draw in my X and Y axis. And then I'm going to put in my acetope. Remember, acetopes are going to be dashed lines. So there's my vertical dashed line. And then I'm going to go to my calculator, maybe get a point or two, just kind of help me sketch it a little bit better. So I'm going to go to my table. No. Okay, so here it looks like 3, 0 is a nice point and 5, 2 is a nice point. So let's go ahead and plot those. So 3, 0 would be right here, and 5, 2. So then I know it's going to follow this right here, and then it's going to start to curve and then follow this out. And then that should match what is on my calculator. And if it makes you feel better, I could put this up here so that everybody saw that I got this from my T-table, 3, 0, and 5, 2. Okay, so let's go try the next one. Okay, for this one, I do not have a log in this problem. So if I do not have a log in this one, then this one is going to be exponential. Plus, you're going to notice that x is a power, and if x is a power, it's exponential. And if you look up here, exponential, it says exponentials start out horizontally. So we're going to say it starts horizontally. And this one has a horizontal acetope, so it's going to be y equals k, and we do not change the sign for k, so we're going to go y equals 3, and we keep that one the same. Do not change the sign. For growth or decay, you look at the b. Okay, b is the one that has x attached to it. So if you look, what's attached to x, that's E. And if you remember earlier in our unit, we said E was equivalent to a number. And we said that E was equivalent to 2.718, yada, 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 yada. And if you don't remember that, then on your calculator, just go second ln, which E will pop up, and then you can type in the power of 1, and it will give you this number. This is bigger than 1, so then this would be a growth. Okay, so now we're going to go to our calculator. Okay, y equals, we're going to clear this out. To get E, we're going to do second ln. And then we're going to type x. We're going to arrow down. And then we're going to go +3. So we're going to hit graph. And then you're going to notice, here's our picture. Okay. So then I'm going to go to the table. And it looks like I have a nice easy point at 0, 4. And then basically the other one I got is -10, 3. So 0, 4 and -10, 3. So I'm going to put these up here. 0, 4 and -10, 3. Let me just double check that and make sure that was right. 0, 4, -10, 3. Okay, so I'm gonna go put my horizontal asymptote in. 1, 2, 3. So here's my horizontal dashed line. And then 0, 4 is right here. And then negative 10, 3 is basically there. So then we're just going to kind of follow this, hit this, and then curve. And we're done. Okay, now some of you might have a question. You might be looking at this and saying, oh, well, why does negative 10, 3, why does that hit my dashed line? So then if I go back to my table, and you'll notice that when I'm scrolling, all of these numbers past negative 10, they all say 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. And here's the reason. My calculator only has so many decimals here, and it can't keep a gazillion decimals. It only has 1, 2, 3, 4, 5 decimals. And then it just is like, okay, I'm just going to have to round these. So technically these are not all really 3. These are going to be like 3.0000000000000000001. But my calculator cannot handle all of those decimals. So it's like, hey, I'm just going to round it to 3. So even though technically it looks like it's going to be touching at 3, the calculator is just saying, I'm rounding it to 3, and that's why it looks like that. Okay, but it's okay that we put it right there at 3. I just wanted everybody to realize that was what's going on. Okay, so the last one, once again, I noticed that x is a power, so this is going to be like our second one here. So this one is going to start horizontally, and it's going to have a horizontal asymptote. So y equals rk, which is -2. This time our b is 1/4. 1/4 is in between 0 and 1, so that's going to make this one a decay. So I'm going to go ahead and put in my dash line here at -2 horizontally. And then I'm going to go get my calculator and type this in. Okay, so y equals clear. Okay, parentheses, 1 divided by 4, close my parentheses, caret key, x minus 5, arrow down, -2. And then I'm going to hit graph. Okay, and then I can go to the table. Okay, and then we can come down here, and it basically looks like probably I can do 4, 2, and 5, -1. So 4, 2, 4, 2, and 5, -1. Okay, so 1, 2, 1, 2, 3, 4, and then 1, 2, and then 5, -1. Okay, so remember it's going to start out here, and then it's going to start to curve, and it's going to start to curve. My pen will work here, and it's going to, come on, pen. Okay, and then it's going to start to curve and go out. Oh, sorry, that's so like sketchy, but you get to the general idea. Here's my flat line right here horizontally, and then it's going to curve and go out that direction, and we are done.